Next question we have this maximum and minimum magnitude. Maximum and minimum magnitude of a resultant of two forces are given, which is a 7 Newton and 1 Newton respectively. So it is saying that when it comes to maximum magnitude of a resultant, we say that a plus b is equal to 6. So this is equal to 7. When it comes to minimum magnitude, so a minus b is equal to 1. And from this two equation, we will get a as a 8. So this is coming 2a. Hold on, minus, and then 2a is equal to 8. So a is coming as a 4. So a is a 4 plus b is equal to 7. B is 7 minus 4. B is a 3. B is 3. Am I? No. Hold on. This is a 2 uh, plus, and here it is a minus and minus. So 2b is equal to 6. 6. So b is coming as a 3. So a minus 3 is equal to 1. A will come as a 4. A will come as a 4. So a is coming as a 4. Okay, till here this is correct. Now find the resultant of two forces when it act orthogonally, which means perpendicularly. Can we say that a is a 4, b is a 3? So c will be what? Magnitude of the resultant. So magnitude of this resultant, we can say this is equal to a square plus b square, and 90 means cos this 2ab cos 90 will become 1. Cos 90 0 0. So c a is a 4 plus 3. Even you can put this 2ab cos theta. It's your desire. If you remove this, then both will be equal to each other. So 4 4 is 16, 3 3 is a 9. C coming as a 5. This is our answer. Find resultant of this. This is our answer. Now next thing. Next thing we have look at our we were discussing about this addition of two vectors, but when it comes to subtraction of two vectors, it is not too much different from the addition of two vectors. In this case, we were saying that a vector plus b vector is equal to c vector. Now I want to get this a vector plus b vector, sum of this two vector, which means magnitude of this two vector, magnitude of a sum of two vectors. Suppose this will be equal to this. It means this mod of this c vector is equal to c. This c is equal to a square plus b square plus 2ab cos theta. That is how we can get magnitude of a c. Magnitude of a c means mod of a vector and b vector. Till here we are crystal clear about this. We also said that this a plus b will be equal to c when theta is, I think, 0. Theta is a 0. Theta is a 0. Okay, we have discussed this about this. And we saw that angle which is made by a resultant vector and is given vector. In that case, we use this formula, which is b sin theta upon a plus b cos theta. This formula is used when angle is made by resultant and a given vector. Then this formula we were using, and this formula is used when we want a magnitude of a resultant vector. Magnitude of a resultant vector. All this now, this part we have seen. What about this subtraction of a two vector? It means we are saying this is one vector and this is another vector. Subtraction of this means we are talking about this a vector a minus vector b. Vector a minus vector b is equal to what? It is equal to what? Yes, this is equal to vector d. Vector d. One thing we can observe over here in this case, that's saying this is one vector, this is another vector. Okay, so this is a and this is b. This will be our d. This is given by the equation, but we can see for this it is not making sense. This is making sense for this, but not for this. This is making sense for this. We will have to convert this into this so that it can make sense. This over here, we are talking about this plus is equal to vector d. We will do one thing. Negative of this positive vector would be what? Just a direction we will change it. The direction. Its a direction will be changed. This will be same. So direction will be like this. Now as you can see, this is our d vector. So it will come in this side. So of course, this will come in this side, and this was our vector a, and this became minus vector. So negative vector of b vector will be like this. Just we will have to change its direction in opposite direction. Magnitude will be same. So now our d will be this. This will be our d. So magnitude of this is our magnitude. Now friend, Initially we had this theta, but now finally we had this alpha. Both are not same. Initially we had this theta, but finally we have this alpha. But first of all, let's talk about this. Can we say this is equal to vector d? So this is vector d is equal to a square plus b square plus 2ab cos how much? Cos, so 180. It is making a linear triangle. So 180 minus theta. We will get this alpha. So 180 minus theta. Okay. Now tell me one thing. Tell me, brother. Cos is coming in which direction? In which quadrant? It is coming 180 minus theta. 180 minus theta. So this is going where? 180 then minus theta. In second quadrant. This is cos will not change itself because we have 180. That's it. But this will become minus. Minus 2ab cos theta. Why? Because it is going in secant quadrant. So in secant quadrant we have a sine theta and cosine theta, not cos theta. That's it. This formula will be used when it comes to this negative vector. Then now what about the tan alpha? This is a tan alpha. We are talking about this. Same here. Our theta will become 180 minus theta. So this b sine 180 minus theta upon a plus b cos theta 180 minus theta. Here you can see this is sine comes in secant quadrant. That's why this will be as it. Why? Because we have 180. First angle is 180. When it comes to 180 and 360, so this trigonometric does not change itself when it comes to 180 and 360. Now what about sine? If this is coming in their home, then sine will be as it. So of course 180 minus theta, it is going, this whole is going in secant quadrant. When it comes to secant quadrant, so two trigonometric values comes, sine and two trigonometric function, sine and cosine. That's why this will be as it, sine theta upon a minus b cos theta. This formula will be used. When we have like that view, like that picture, like that figure. Now let's take equation for based on this concept. We have seen addition of a two vector, subtraction of a two vector. Product of vector we will see. There is a separate part for discussion about magnitude of a two vector. product of a two vector. There is nothing for division vector. No. Look at this question. Look at this question. Here we know that magnitude of a vector, mod of a vector and b vector, it is equal to mod of a c vector. Mod of a c vector. So formula will be we will calculate three things from this same question. From this same question, we will calculate three things. Look at over here. If a two vector, there are two vector A and B has magnitude 10 Newton. It means A is a 10 and B is a 20. Such that angle between them is 16. Angle between them is 16. Find this. It is providing this. This is equal to, we know, mod of vector A and vector B is equal to mod of vector C is equal to C. So 10 raised to power 2 plus 20 raised to power 2 plus 2 multiple 10 multiple 20 multiple cos 60. Yes, it is under root. Now 10 raised to power 100, this will become 400, this will become 400, cos 60 is nothing but 102, 1 by 2. This is cutting by 200. So 500 plus 400, it is equal to 900, which is a perfect square of a 30. So finally, C came as a 30. Magnitude of the C vector is 30. This first point is clear. Okay, now next. Try to understand. There is an angle which is made by resultant of this vector with A. So when it comes to angle made by resultant, then we use this tan alpha. B is how much? 20. Sine 60. Theta is 60. A is how much? 10. Plus B is 20. Cos 60. Cos 60. 20 multiple. Sin 60 is root 3 upon 2. 2 is cutting this 20 by 10. By 10. Okay, by 10. Now 10 plus 20 multiple cos 60 is equal to 1 upon 2. This 2 is cutting this 20 by 10. Over here we are getting how much? 10 root 3 upon 10 plus 10, 20. 10 to the 20 root 3 by 2. So tan alpha came as a root 3 upon 2. Root 3 upon 2. Now next, third point. Magnitude of vector A minus vector B. It is talking about this. When it comes to subtraction of two vectors, we do one thing, which is what? Sign will change also, sir. A square 10, I think 10, 20 plus 2 multiple 10 multiple 20, then we have, but here this plus will become minus because we are doing subtraction of two vectors. So cos theta is 60. Now this is correct. 100 plus 200 minus 400 minus 1 upon 2. 200. Okay. So this is a 400. 500 minus 200. 300. This is your answer. These are three things that we got from the same question. Now, one thing more you can find tan alpha for this. So here B sine. So B is a 20 and sine 60. Okay. A is a 10 minus. This sign will change itself when it comes to subtraction of a two vector thing. So here B is 20 again, cos 60. 20 will be as it, sin 60 root 3 upon 2. This 2 is cutting this 20 by 10 upon. So 10 minus 20, cos 60 is equal to 1 upon 2. 2 is cutting again this by 10. So 10 root 3 upon 10 minus 10. This will become 0. Wow. I think it is in, this is undefined. This is undefined. This will be your answer, which is not defined. Yeah, not defined. 0 is in denominator. That's why we can say this 0 is not defined. Now, next topic, we are going to move on next topic. Next unit vector. Unit vector. You are already familiar with this unit vector. Yeah, you might have some information about this, but it will be enough, brother. It will be enough if you have some information. When it comes to unit vector, we know that magnitude is going to be 1. This is 1 point. Unit vector has a magnitude only 1. Direction magnitude, this 1 will be always forever. Okay, so it is used for especially direction. To give a direction we use this. Okay, so symbol for unit vector would be what? Symbol is like this: a cap, b cap, I cap, j cap, k cap. These are symbols: I cap, j cap, k cap. Remember, this cap is being used for direction. Magnitude is 1. Okay. I am not saying that it is not vector. This is vector because vector word is added with unit. And next, this is a unit. It is a unitless. This is a unitless and dimensionless. Okay, I have dimensionless. This unit vector is unitless, and this is a dimensionless. This unit vector does not have dimension as well as a unit. We are going to see, our full attention will be on unit vector. Don't worry. Now tell me, in the starting of this lecture, I was telling you that this A vector can be written as, this is a multiplication. This is equal to multiplication of magnitude, which means A, multiple direction. So direction is nothing but this A cap. Cap is a direction. This arrow. We are talking about this arrow. So for what is the direction? For magnitude we have A. So for direction we have A cap. So can you say that this vector A is equal to magnitude of this vector A multiple direction. Now a lot of question will be saying that find a unit vector along with this axis. So that's why from this we are getting A cap. So A cap is equal to vector A upon mod of vector A. So remember, this A cap is equal to vector A upon mod of vector A. Okay, this is our one equation. There are a lot of equations based on this equation. Don't worry. This is not equation. A cap is equal to, how did it come? So it came from this. From a definition you can see. Are you crystal clear about this? Now, if you see, this magnitude of A cap will be what? Here we are trying to find magnitude, only magnitude of A cap, not a direction. So magnitude of this A, we will get only 1. If you say that this A cap is equal to 1, then this will be wrong, because this has what? This has direction. So to remove direction, we will have to use this mode. Okay. So now this is equal to 1. As we were saying, this vector A is not equal to A. To say that this is equal to A, so we will have to use this mode. Now this is equal to A. Okay. Now look at it. We have a vector, this vector, A vector. Let's just say magnitude of this vector is a 6 Newton. So 1 Newton will be till here. So what is a cap? A cap is a nothing but it is a along vector. This A cap is a along vector. This is a cap is a along vector. So over here this will come. This is a cap. Whose the magnitude is a 1 and direction is along this vector. Direction is along this vector. Okay. Let's understand this with another example. With another example. Cartesian plan. There is a person who is running with velocity of 20 meter per second. There is another person A who is running with 10 meter per second along x-axis. So how would you say that B person is running with this much velocity? You would say velocity of A person is how much? 10 meter per second. 10 meter per second. In which direction? When it comes to direction, then in which direction? You would say along x-axis. Along x-axis. This is what you will say. Now, velocity of a B person is 20 meter per second along y-axis. Along y-axis. Rather than saying along this axis, along that axis, we can replace this by I cap, by z cap. In the language of a vector, this x-axis is replaced by I cap, this y is replaced by j cap, and the z third dimension is replaced by z is replaced by k axis, k cap. Okay, k cap. Here you can say, for this you can say 10 meter per second I cap. Anybody will be attracted with this 10 meter in which axis? On this, in this direction, horizontally. This is going horizontally, positively. Okay, positively. Now for this 20 meter per second j cap, vertically it is going above vertical. We have addition sign over here. Now what if let's say it is going this side with a 5 meter per second. So this will be become our minus j cap, minus j cap. Okay, this side mm, not j cap but x I cap, and this will become our j. So as you know, this is our negative 6 meter per second, 6 meter per second. Okay, okay, no problem. Now we will say this is C and this is C. So velocity of a C vector is a 5 meter per second minus I cap. Minus is important. Velocity of a D vector is a 6 meter per second j cap. That is how we communicate with this I cap, j cap, k cap. So finally, you understood. There are three axes on Cartesian plan. Third axis is this z. So it will be replaced by k cap. Now unit vector of x along x axis, unit vector along x axis, along positive x axis, this is known as, so unit vector of along a positive x axis, it will be our positive a cap. Unit vector along positive y axis will be our j cap. Unit vector along positive z axis will be our k cap. Unit vector negative x axis will be our minus I cap. Okay, unit vector along minus k minus y axis will be our j cap. Okay, minus j cap. Unit vector along minus z axis will be our minus k cap. All these are main points that we will have to remember. When we are in the lecture of vector, and this vector will come in the lecture of motion in a straight line, motion in a plane. Okay, so unit vector along x axis will be our I cap, and unit vector along y axis will be our j cap. Unit vector along z axis will be our k cap. Now here, look at it. There is a coordinate, this 3, 4. 3, 4. 3, 4. Do you know position vector? Position vector is a vector which starts from origin and it ends at the location of a particle. there is a coordinate which is a 3 comma 4. This is a 3 comma 4, 3 comma 4, and let's say this is a particle. What is the location of a particle according to origin? We would say this is our a vector. This is going to be our a vector according to references origin. Over here reference, our reference is origin. With respect to origin, this is the location of a particle. Now try to understand what is the meaning of this coordinate. It is saying 3 is our this particle covered 3 unit in 3 unit I cap. So till here 3 unit. How much? 3 unit. And 4 unit Z cap in upward direction like that. So 4 unit. Can you say that location of A is a 3I cap plus 4J cap? This is our complete communication to tell location of anything. So location of A is a 3I cap plus 4J plus 4J. Okay. Now next, okay. Now what if there are 3 axes? There are 3 axes. Not it is saying that particle covered 3 unit along x-axis, 4 unit along y-axis, 6 unit along z-axis. This is what is the meaning of this coordinate. Now we will say location of a particle is 3I cap plus 4J cap plus 6K cap. 3I cap plus 4J cap plus 6K cap. This is location. Here to go over here, we will have to cover this much along x-axis, 4 upward, 6 in front, 6 in front. Okay, that is how we are able to interact with these coordinates in the language of a vector. But remember, all these are locations according to, with respect to origin. With respect to origin, reference can be changed. Reference will be different. Look at over here. Now we are going to change reference point. Reference point. What was location of a vector according to origin? We have seen. Now there are two particles. Otherwise you can say there is one particle. Initial location of this particle was over here and final location of this particle is over here. Okay, so according to Cartesian plan, coordinates are 3, 4, 6, and when particle came to this place, coordinates became 4, 8, 9. So how much this particle covered this much displacement? How much? So position vector with respect to B, let's say now name of this location is B. So position vector of this B with respect to A. B with respect to A will be our. So our reference point in this case we have A. This is a reference point. Location of this with respect to this. Location of this with respect to this one. This location. Okay. Can you say 4 minus 3 square, 8 minus 4 square, 9 minus 6 square? Distance formula we are using. Distance formula. Distance formula. So here you would say 4 minus 3 I cap plus 8 minus 4 j cap plus 9 minus 6 k cap. So this is coming as a I cap plus 4 j cap plus 3 k cap. This much we will have to go this much. One unit along x axis, 4 unit along y axis, 3 unit along z axis. Then we will come to this. But remember, we are over here. From here we will cover this much distance. From here, not from origin. Okay, not from origin. So from here we will have to cover 1 unit along x axis, 4 unit along y axis, 3 unit along z axis. Then we will come over here. So this much distance this particle covered, this particle displayed. Now let's change our reference point. What is the location of this A vector with respect to B? With respect to this B. In that case, position vector of A with respect to B. In that case, this from this from this. It means now we are going to use like that. 4 minus 3, 4 minus 3, 3 minus 4, 3 minus 4. We are going to find location of this from here. 3 minus 4. Yes, 3 minus 4. 3 minus 4. 4 minus 8. 4 minus 8. Okay. 6 minus 9. 6 minus 9. K cap. Minus I cap plus minus 4 J cap minus 3 K cap. Now look at over here. I am going to use this. This part is done. This part is done. Next. Next. Next thing. Next thing we have A is over here. Initial location of a particle is over here. 3, 4, 6. Okay. According to this is a location according to origin. Let's just say this vector. Okay. Position vector of A. Position vector of B. This particle went over here from here. So now coordinates became 4, 8, 9. 4, 8, 9. This much. According to origin till here, this will be our position vector of a B. Position vector of a B. This B. And this is nothing but position vector of A with respect to B from here to till here. Can you see triangle now? Is it making triangle? Yes, we can see this plus this. We will get this hypotenuse. Am I correct? So position vector of A plus position vector of A with respect to B is equal to position vector of B. This is what we are getting from this diagram. To calculate this much displacement, can't we say that position vector of A with respect to B is equal to B minus vector R position vector of A. This thing can be used. When you will use this equation, you will get this much displacement, where coordinates of A and coordinates of B. Now let's say coordinates are 3, 4, 6. So position vector of A according to B. So this we are talking about this 4 minus 3. 4 minus 3. It means x2 minus x1. x2 minus x1. x2 minus x1. So 4 minus 3 I cap plus y2 minus y1. 8 minus 4 j cap plus 9 minus 6. 9 minus 6 k cap. We are calculating this much displacement between A and B. Reference point is reference point is B, I think so. Position vector of A according to this way. According from B to A. So I cap plus 4j plus 3k k cap. This is our displacement from B to A, from B to A. Now brother, magnitude of A vector. Magnitude of how to find so how to find magnitude of a vector. Magnitude of a vector. For example, location of a vector is given. So location of a vector is let's just say 3i cap plus 4j cap plus 6k cap. Okay, this is the location of a particle. Now, how to find only we want magnitude, nothing. Magnitude of this would be what? Only magnitude without having direction. Without having direction. So for this we will use simple formula. So magnitude of this would be all this are square, magnitude of this and this and this raised to power a square. So 3 square plus 4 square plus 6 square. Okay. So magnitude of this we will get 3 3 is 9, 16, 36, 25, 36, 1, 6, 61. 61. This is your magnitude. This is your magnitude. This is your magnitude. Okay. That is how you will calculate the magnitude of any vector whose coordinates are given. Okay, coordinates. For example, now we have vector B. So location of a vector B is what? For example, 2i cap plus 4j cap. Okay. So only to get the magnitude, we know that we will use this mode. So this will be equal to 2 square plus 4 square. So 2 2 is 4, 4 4 is 16. This will be equal to 20. Root of 20. Root of 20. Okay, so you will use this formula. You will use this formula. You will use this formula when coordinates, location of a factor is given. Then you will use this formula. Simple. X square plus y square plus z square. Okay. You will use this formula. C is equal to a square plus b square plus 2ab cos theta. It will be used when we have two vectors. So in the discussion of addition of two vectors, then we will use this formula. But when it comes to location of a particle, location of a vector, and then only we want a magnitude, then we will use this formula. So in this formula we have coordinates, but in this formula we have a angle and two vector. Angle and two vector. Now let's take. Remember, one thing I would like to tell you over here is 3i cap minus 4j cap. So this is equal to this much. Location of this vector is this much. Now remember, this minus will become addition. when you will use mode, this mode. So this mode is used to have addition, So 3 square plus, it will become plus 4 square, 4 square. Okay, this is the right method. If you say that this will be 3 square minus 4 square, then this will become wrong method. Okay, wrong method. So 3 3 is 9, 4 4 is 16. That is how you will solve. At the end you will get this much. Don't say that we have also minus 5. No. Here we used mode. That's why we can't say that we have minus 5. Minus 5. Okay, minus. Not minus 5. Only positive 5. Only positive 5. That's all.